There we go, the best stream is live and brand new video right here, just got uploaded. I mean, it was a stream, so let's do the last stretch, the last stream ever on this channel before it's rebranded and stuff like that happens. Okay, so we've got this essentially LOG stuff. Well, I said that I'm pretty good with essentially algebra, but this one looks a bit tougher than usual, so yeah, with many LOGs. I got formula sheet if I need it, so yeah, I really have no issue in starting this. LOG 5625, so 625, I think it's 25 of power of 2, and as it is 25 at the power of 2, we can write down as 5 at the power of 4, so LOG 55 disappears, so all that will remain there is LOG2 of 4, so that's LOG2 base and 2 power of 2, so all that remains is 2 right there. And after that we have LOG3 base and 81, and 81 is 3 power 4, so square root of 4, 2, so yeah, I think that's done. In terms of exercise 2, it's pretty easy to write there. So just quadratic and stuff. Next up, it's a kind of geometry problem right here. So we got this shape right here. Base is BCAD. There's a circle here which I don't really like, so skip this one a bit. In terms of a polynomial, so basically you got this polynomial and 3 is a root, so we just pop 3 and that's pretty easy. And in terms of finding out the other roots right here, what I need to do in order to find that out, well, perhaps I need to divide by x minus 3, this one I don't really remember, or p3 is equal to 0, I need that. Well, yeah, because we got an a there. So if we plug in the a, we will get exactly this, so now we should divide it by x minus 3. Okay, so I was right. P3 is 0, equal with 0, as it is a root, divide, and in terms of this, I remember the polynomial division, no problem, I'm a genius. Boom, x minus 3 right there. Parentheses open like that. All of that. What we get, we equal to 0. We essentially plug it in there. We solve x1, x2, so we pop it like minus and so on. Minus 2 and divided by 3. And what? I think there's some explaining here and like whatever. No issue right here. This obviously inversible, this is some sine stuff, so obviously I don't take Gaokawa and stuff like that, so and skip this. So right here I could try to look through this geometry problem go a bit back. And let's think about this. Basically, there's this cone, and the base has the OB 15, so essentially AO is also 15 because there's the same they're the same length, and there's a parallel section 24 centimeters away from the point at the very top, and basically the line VB right here on the drawing is 26. We need to find the volume of a cone, which is essentially what, I don't know, 1 divided by 3 times the area of base times the height. I don't really remember the formula right there for that. But a man is what, 26 to the power 2 minus 24 power 2. Is it actually that? Yeah, because actually Vn is 26, not Vb. It's a that small triangle of small cone. So yeah, obviously we can find out Mn, and it's pretty easy using the Pythagorean theorem. 26 to the second power, how much is that? That is, what is 2 times 50, that's 10. Using some kind of method. So Vmn is kind of the same as VOB because yeah, they're kind of the same, but just one's bigger like that. This goes down more. And using this relation, angle-angle relation, perhaps Vm divided by VO is the same as Mn divided by OB. Can't remember this one, but it's pretty geeky, so. The maximum value, bro. I've done 10,000 practice exercises, and never have I ever encountered this. Find the maximum value of a function. How the hell am I supposed to know that? 7 minus that equal with y. How the hell am I supposed to know that? Well, obviously, minus this is equal with y plus 7, right? Minus 7 because the sign changes, yeah. So y minus 7 right here. And what can I do now? Well, the minus 3 is near the square root. And so what? Should I actually go and divide the expression override by minus 3? We can remove a negative sign, and we can flip the signs like this, whatever. And in terms of this, yeah, I can switch around like this, whatever. Has to be bigger or equal to 0, and this one also, for some reason. And so what? This right here, with that, what? We can plug in what? Minus 2? What do you plug in? So just ignore that, and y is smaller than and equal to 7, so it's from minus infinite till 7 like that. Well, I guess kind of I get it, but not that much. So, yeah. In terms of this, obviously, skip it. This binom thing is good. Right here. I don't even know if he's gonna do probability. Is he actually gonna do probability? Bro, if he does not do probability minus respect, like come on, probability is like the main thing. I mean, for me, for math geeks, it's not that of a main thing. So let's just do this. So we got this binom, add the power of n, and the binomial coefficient of a third term is 105. Find the number of rational terms. So got all the formulas there. Honestly, it's too much formulas. I know them pretty much all. So yeah. Now what we can do? Well, it says here the binomial coefficient of a third term is 105. So what's the binomial coefficient? It is the c. So we just write down the c of that equal to 105, and we have n. And then we will basically find out the k, which indicates the number of terms. So that's it, I think. So we'll have 5. So we're working so far with this square roots and so on. We'll have 5 at the power of 1 divided by 3 plus what? Plus square root of 3, which is 3 at the power of 1 divided by 2. But why did this guy write it down as 5? Maybe he did a mistake. Because you can clearly see there that it's 5 under square root, and then on the second square root is 3. Maybe he did a 3 there, I don't really know. Anyway, so of a third term is Cnk formula, so k is 2 plus 1, so k is 2. So Cn2 is 105, so just solve that. Pretty much no issue. Yeah, free right there. Goddamn freeloader. Stream will be on about like 1 hour and a bit more, stuff like that. Just the best time frame I can provide. So I have n minus 2 there, which is correct. So we need to simplify this n minus 2 exclamation mark. So how to do that? At the top I just have to write down n minus 2 exclamation mark and then n minus 1 and n. And I'm gonna simplify 2 exclamation mark is just 2. So that's how you write it down. Like I just said, 2 right there. Simplify appropriately. Okay, so simplify, and you're gonna have n at the second power minus n equal with 210. If you crisscross it and do everything in the best way, you're gonna move the minus 210 to the left, or this guy will go with what, factorization, and is 210. What's gonna do? 15 times 14 is 210. Yeah, that's correct. And so what? So he left it like this for now for some reason. I thought he's gonna use viat or delta to find out the k, but he just writes down the stuff. I mean, perhaps he already found it out. Okay, so he did it with viat or stuff, or some other thing. 15 is the k because that's how you get here. N minus 1 is, it's essentially 15 minus 1 is 14, so that's kind of a meta here. So he found out that n is 15, and now he just plugs that in right here. Okay, so we just need to find out the k, so that we can find out the number of terms. So we're just going to do k plus 1, and that's the terms, and we don't need to calculate the actual term, we just find out the t, and that's it. So C15k right there times 5 to the power of 1 divided by 3 for first term, and all of that at the power of n minus k, which is 15 minus k. So we can just time them right like that. So it's going to be 15 minus k divided by 3, and k right there, so 3 times that. So we got c 15k right there. Okay, so now 5 to the power of 15 minus k divided by 3 right there, and times 3 to the power of k divided by 2. Boom. And after this, it has to be a rational term from the condition, so we have to understand the number of rational terms. So I think we just work with the powers, or what? 15 minus k divisible by 3, what? K is divisible by 2, so we just need rational terms like that in order to find the k. Okay, so I guess this is how this one's done. So if I would have done essentially what 15 minus 6 out of get to 9, which is divisible by 3, and instead of k, if I put 6, that is also divisible by 3. So pretty much k is 6, but the thing is, I don't think you can just say 6 like that, so you kind of need to prove it and so on. So yeah, sometimes you have to do that. So this is how you prove it. So k is divisible by 6, so k is smaller or equal to 15 in the c, so it can also be 12, that also matches, and it can also be 0. I don't know why 0, because 0 is not actually divisible by 2, or is it? I don't know. So it's actually 0, 6, or 12, so you do 0 plus 1, that's t1, t7, and t13, so 3 rational terms. So this one's pretty tricky, didn't quite do a lot of exercise like this, but no, I pop it in best way, so it has to be natural like that. So okay, boom. Okay, of course it's natural like that. What? Hold on. The probability is what? No way. Bro, he did probability. How I missed that? How I missed that? I thought Ian did it. Must have done it. I've seen it. I've just seen it, mate. When you did it. This looks like a graph. What? Limits here. Okay, so you did it right here. Ooh, good stuff. Nothing missed. Of course, this guy's a businessman. This guy knows his stuff. He's the best guy. So, of course, probability is present here. And let's just do it. There's essentially a movie festival, and the organizators offer prizes consisting of tickets to 3 different sections: action, comedy, and drama. A group of 5 friends wins. Each one of them wins a ticket, and each of them chooses randomly a section. So as you know, there are 3 sections. And what's the probability that 2 friends to choose one section, and 2 friends to choose another section, just one to choose the last section? Okay, so let's try to understand how this one's done. Obviously, we got 5 friends, so we got 5 circles like that. Formula, I've got it. Always start with the total number of cases, then work through with favorable cases right here. So in terms of total number of cases, we got 5 friends and 3 sections. It sounds pretty hard in terms of even the total number of cases. Yeah, because how exactly am I gonna do the favorable cases? I think favorable cases should be also easier here, perhaps. But of course, that's not essentially proven until I go through it. 5 circles like that. Really have to think this through how I can get the total number of favorable cases right here. Yeah. 5 friends, each with a ticket. 3 sections. So isn't it like something like C5 free? Like out of 5 friends we choose 3 sections. Perhaps no. Or it's C5 free times 5. Because there are 5. Or C. Bro, this one's pretty hard. If I just try to understand by the circle, so there's first circle, first friend has 1 ticket and needs to decide between the 3 sections, so we got 3 cases, so is it actually just 3 right there? Or 3 exclamation mark? What is just 3? Okay, so the second one also has 3 selections, so is it actually just 3 power 5? Okay, so boom, 3 power 5, kind of I got it correct. So kind of I got it correct. It's kind of like the fucking dice right here. So another dice, when it's the dice, it has 6 faces, so it's 6 base, and then the power is how many times you throw it. Here it's like kind of the same. The base is essentially how many selections there are, like the size of the dice, and the number of throws is like the number of friends here that I have to choose. So yeah, kind of the same like when you flip a coin and so on. So now let's go over the favorable cases right here. So right here, I got the favorable cases, 3 power 5. So obviously for favorable cases, I'll just do 5 circles again, right? I wanted this guy to just write down 5 circles so that I can think it through, but I guess we're gonna go with 5 circles from the end, which are still there. Let me switch back to see everything. So 3 sections, and what is the probability that 2 friends choose the section action, 2 friends choose the section comedy, and 1 friend chooses the drama section? Well, bro, right here. Right here. Um, 5 friends. So I just do with circles, right? So the first one, first two ones, so it's basically C21, and then the next two ones times C21 again, and then just my god, this one's pretty hard, bro. How am I supposed to find favorable cases here, bro? Really, how am I supposed to do that? If I think about it again, I said C21 because out of two friends they choose one section, but then again, each friend has a selection of 3 movies, and bro, it's kind of difficult. 2 from 5, yes. Can I get a hint? 2 from 5 gets comedy. 2 from 3, huh? Yeah, 2 from 3 because because 2 already chosen. So 2 from 3 choose comedy, and 1 from 1 chooses the drama. So what leaves that? C52 times C32 times 1, right? As far as I know. Kind of a hint. Okay, so yeah, I got it correct. I mean, kind of I needed that hint. Perhaps if I thought about it more, maybe I'd have guessed it. But it's not that certain, and could have taken quite a time, so just I think this approach of just getting the hint, like in those fucking games where you pay to give a hint. So basically I got it, and there it is. That's correct. So C11, that's just 1. C52, I don't know how much is that. Perhaps it's 6, and or C32 is 6, I don't know. C32 is 3, so right there we have this 1, 2, 3, 4, 5, and that. So times 3, 1, we just don't even write it down. So we simplify 3, 3. We simplify 2, 4. 2 right there. So it's gonna be just 10. M is 10. Actually 30. Yeah, 30. And we just pop it there. So you're gonna have 30 and 3 times 3 and a 4th power like that. So 10 divided by 81, right? So 10 divided by 81 right here. Okay, so we got this now. I don't know what else can I watch. I mean, I watch that binom right here. This triangle right here is fucking with relations, so cos, which is pretty hard. This figure stuff is pretty hard, ln and stuff. So yeah, kind of for this video, let's go to number 1. There's no issue because I have it right here. I mean, I was kind of watching this. So let's close this one. Drink a bit of water. And this cone is with a circle, so I'll just skip this honestly. This is with a sign, so skip instantly. I don't want to deal with this. Parity, parity, bruv, parity. Bloody parity.
Fosfor tekçe.
So, bloody parity. I mean, in terms of bloody parity, I kind of remember how it's done. But I'd say the best approach is not to skip it, just to watch it. It's quite easy, you just need to know the thing. You just need to know when you study the parity of a function, of a relation, essentially if f minus x, so when you pop minus x, is equal with minus f of x, essentially the function, I think it's even, or stuff like that. And if f of minus x is equal with f minus f of x, then it's not even, stuff like that. So first of all, I need to fucking place it with f and minus of x. So instead of x, you just write down minus x and plug everything in right here. So module of minus x is going to be x, so minus x power 3, x plus 1 below. All of it's minus like that. And so we have understood that f of minus x is essentially minus fx. So that leads us to that it's essentially even, or it's actually odd, so it's odd. So this is the relation, it's odd like this. And I think it's, you can check online, whatever, bro, if it's f minus x equal with f and minus x, then it's essentially even. Yeah, kind of. So let's just get going out of here. Bro, this is like with signs, so obviously let's skip it. Limits right here. Skip that. Graph calculation with trigonometry. Leave that for the geeks right here. This one already did. I actually did, bro. Let me tell you a fun fact. I did this test. Yeah, at high school I did this. And I got a decent mark. I mean, obviously, I passed, but obviously not a geek level, so above average, that's it. So I didn't know how to do this one. Didn't know formula, the exercise 9. And yeah, obviously now I kind of remember how I did this stuff and how I got this stuff. Bruv, I said I was a genius, but look at this. I couldn't like even remember properly that I already did this test. But now I remember. Now I remember I solved probability and stuff, so I did it all. But probability I did. I got max points, so I'm a genius. But in terms of the binomial Newton, I didn't get it quite clocked. Like, I didn't know the roots so well. So I didn't do shit at the last exercise. So now I'm gonna do shit. So I kind of remember to do this one. Let's just do it for fuck's sake or practice sake. Yeah. But I've seen examples of exercise how this is done, which are pretty similar. So yeah, perhaps there's gonna be a quick swipe through. So essentially the sum of binomial coefficients in this decilitation is equal with 4096, and we have to find the middle term within the decilitation. Okay, so in order to do that, what I need to do, essentially, um, well, sum of coefficients, so basically that's 2 power of n equal with 4096. So then you think about what power you need to put to 2 to get 4096, so that's like 12, so n is 12, so then you solve for k using the general formula, and then you kind of do the middle thing, so k divided by 2 plus 1, and you got the t number, and then you solve it and you write down, and that's essentially what you need to do right here. So, and it's 12. I got that right. And then now just let's try to solve it. T of essentially we don't know what. K plus 1 of metals n divided by 2 plus 1, so it's actually this, so yeah, it is actually this, which quite makes sense because we don't have anything to grip us through to get the k, so we get the k like this. So we're gonna have 12 divided by 2, which is essentially 6, so t7 we have it right here, but t7 that's t6 plus 1, so c12, so 6 right there, x to the power of 2 right that, so yeah, like, I pretty much kind of remember this stuff, so stuff like that, and 3960, I mean, yeah, like, whatever. This is how it's done. But why did the guy do like this? Where the x went like that? Separated the x essentially. Okay, I guess that kind of makes sense, but it's pretty tricky, so might as well watch till the end, just to get the bigger grasp of this. So we're gonna have right there this, that, right here, x to the power of minus 6 right here, because it was below, and with the power of k we get like this. So the c we just write down like this. C12 6 is 924. Jesus, honestly I didn't expect a number this big. So right there we have obviously x to the power of 12, and right here we have 2 power of 1 divided by 3 times 6, so that's power to 4, negative 4 essentially. But where did the negative sign go? Oh, it's all at a positive power, so fucking disappears, so x minus 6 right there. And we will have essentially 924 times 4, and x12 minus 6, x6. X power of 6, not BMW x6. 3696, x6. So we're gonna write down the response t7 is 3696, x power of 6, right? Yeah, I think that's about right. Video has been concluded. And now let's go ahead and watch the other best video. I think this one's quite good, right? Okay. Yeah, Math plus MD. They're the guys that do this. I just review their videos. I don't know how this is called, just learning through commentating. So this is kind of easy, no problem. In terms of exercise 2 right here, we got this polynom, and we need to understand value of real parameter a, knowing that p of x divided by q of x, x minus 2 is equal to 3. Let me think about this. So yeah, we got a p of x like that, obviously, and we gotta find out the letter a right here, knowing that, so right here p of 2 is equal to 3, right, in terms of x size 2, and just find out a. And yeah, p of 2, you get it, and you equalize it with 3, right? Yeah, bruv, easy as day. Boom. In terms of x size 3, find real values p and q, knowing that no complex number for which the complex number 3 minus 1 is a solution to the equation. Kind of didn't fucking encounter stuff like this, so I don't know exactly how this one's done, so might as well grasp it through to understand what kind of thing we can do here. Find the real values of p and q for which the complex number 3 minus I is a solution to the equation this. Oh my god, how am I supposed to do this? Yeah, let's watch this. I kind of don't know how to do this one. I mean, it's kind of in reverse, like you have to go from the solution to the things that were initially in the quadratic thing. How am I supposed to do that? It's one of the solutions, bro. I really don't know here, so just watch it. Yeah. Let's just watch it. It's that easy. It's that easy. All you need to do is just plug in 3 minus I. I mean, I guess I could have guessed that because it's the solution, so it's like x. Bravo. Didn't guess it then. Perhaps if I stayed longer, I could have guessed it. Okay, so you do this, and you get what you get. You just work with real values and imaginary values split like that, so you get q and p. And I guess there's another method too. z1 is this, so z2 is 3 plus 1 or what? Yeah? And so what? And so you can go with the yet stuff, right? And so we have x1 plus x1 is going to be equal with minus b, and that with that is going to be equal with q. Sounds pretty tough, so honestly fuck this method. Like, I'm just gonna get this stuff and that's it. Okay, so now I have this right here. Find real values for which of x for which the matrix is not inversible, so I think it's equal of 0 this matrix, right? Am I right? Yes, I'm right, of course. And using this fact, I just now solve this determinant, right? It has this kind of tricky log22, but I guess I can kind of can get it, so on. I'll see. So I just need to expand it till the end, 2 more rows. Or it's going to use the star method, I already know. So we're going to have this. And from here we have the same thing. So 2 log 2 x to the second power. So yeah, this one's 8 points. This one could work in the test as a replacement to the obviously to the trigonometry, so it could be a bit hard, so in that case I could skip it. So kind of I can skip it right now, but I guess it's kind of a really good approach to just watch it right now, kind of trying the best approaches. log22 minus x, so that's how it was initially. He used the star method to get this thing. I don't use it ever because I don't really remember how to use it. I just use the simple stuff, just write down the row 2 times and then diagonally 3 times and then times minus the other 3 diagonals. That's how I usually go with it. So now he wrote down about like the same. Now we've got 2 log 2x power 2. I mean, we can move a 2 and get x power 4. But other than that, where'd the 2 go? Where'd the 2 go? He wrote down the same thing, but oh, that's where he went. So essentially we got the 2 minus like that, so we got this. Okay, that kind of makes sense. And looking at that first log base 2 and the 2 above it, I think that the 2 above it means that essentially it's the second power, but minus x perhaps. So if minus x to the second power is going to be x to the second power, so we can just plus them out as far as I know. But this guy says we can also do minus x right there because second power, so it's going to be good. So now what? Now it's going to be log3 or what? Minus x plus 2. What? The same stuff and then 2 again and then yeah, basically pretty complicated this one, so might as well skip it. Obviously sin and cos, skip that. I am off to this first geometry problem, which should be like the easiest one of the test. Let's see how I do here. We got this 90-degree triangle, so it's 90-degree and essentially the A angle, ABC triangle like this. M is the middle segment BC right like there, and ME is perpendicular with AB like that, which from the drawing we can see it's true 90-degree angle right there. And we know that ME is 5 square root of 3, right? And BC is 20. We gotta understand the measure of ABC. So essentially the measure of angle B right there at the very top. ME is 5 square root of 3, BC is 20, M is like where? M is in the middle, so essentially BM is 10. BM is 10. 5 square root of 3 right there. And I mean, it should be like a 30-degree angle right there, because using that 30-degree theorem, we got a 10, we got 5 square root of 3, and we got 5 right there, BE. And yeah, that's it, I think. A 10 right there, 10 right there, 5 right there, so 30 degree. So 30 degree there, so 180 minus 90 minus 30 was 60 right there. 60 right there, mates. In terms of circles, obviously it's more complicated here. Let me see. Yeah, sine and stuff. I'm not Chinese, I don't know this stuff. It's kind of like complicated, so yeah. Here with monotonia, I mean obviously it's quite easy, m plus 1, plug it in, and do minus an. Yeah, but I also saw a guy like, he did it like plug in 1 and then 2 and which one's bigger and so on. So yeah, it's kind of like this for now. Off to this fucking shit. So now this, I mean obviously right here we've got a bunch of, hold on a second, hold on.